In the next set of problems, we're going to look at word problems that involve either the law of sines or the law of cosines. For the law of sines, the rule says that side A over the sine of angle A is equal to side B over the sine of angle B, which is equal to side C over the sine of angle C. And in order to use this, what you need is the side and the angle across from that side. For the law of cosines, all right, this says that side C squared is equal to side A squared plus side B squared minus 2 times side A times side B times the cosine of angle C. And basically what you need here are two sides and the included angle, or you need all three sides in order to use that one. Okay, so let's take a look at our first example. I've drawn in some triangle ABC, and they tell me in this triangle that angle A is 20 degrees, so I'll go ahead and label that as 20 degrees. Side A is 10. Well, the side that's A is across from angle A, so this side over here is 10. And the side C is 11, which is across from angle C. Angle C is here. Across from that is side C, which is 11. They want us to find the measure of this angle right here. And since I'm looking at sides that are across from angles, I can use the law of sines. And so in this case, I'm going to do A over sine A is equal to C over sine C. And now I'll just substitute in my values. Side A is 10 over the sine of angle A, which is 20 degrees. That's going to be equal to side C, which is 11, over the sine of angle C. And again, angle C is what we're looking for. Okay, so I'm going to use my cross products here in order to help me solve this. 10 times sine C, 10 times sine C is equal to 11 times the sine of 20. 11 times the sine of 20. Okay? And so in order to get the value of the sine of C, I'm going to divide both sides by 10. So the sine of angle C is equal to 11 times the sine of 20 all over 10. And now in order to get the value of angle C, I'm going to do the inverse sine. So it's going to be the inverse sine of 11 times the sine of 20 all over 10. Okay? And so I'm going to go ahead and I'm going to punch this into my calculator here. Okay, I'm doing clear out of this. All right, I'm doing the inverse sine of 11, I'm going to actually open up another parenthesis here, 11 times the sine of 20 divided by 10, and I get this decimal here, 22 and 0.998698, and so I'm going to say that this is approximately 22 degrees, okay, to the nearest degree. Angle C right here is about 22 degrees. In example 2, I'm told that angle C is 16 degrees. I'm going to label that as 16 degrees on my triangle. The side B is 92. That's across from angle B. This is 92. And the side C, across from angle C, is 32. They want me to find the measure of angle B. So what is that measure right there? So again, I'm looking at sides and angles that are across from each other, so I'm going to use my law of sines again. B over sine of angle B is equal to C over the sine of angle C. So now when I substitute in, side B was 92, sine angle B is what we're looking for, equals side C, which is 32, over the sine of angle C. Angle C is 16 degrees. Okay, and so now I'm going to give myself some space here. I'll do my cross products. 32 times the sine of angle B equals 92 times the sine of 16 degrees. And so if I divide each side by 32, the sine of angle B equals 92 times the sine of 16 divided by 32. And so now I'm going to do the inverse sine of all of that in order to get the measure of angle B. Okay, so punching this into my calculator. Okay, clear that out. Inverse sine of 92 times the sine of 16 divided by 32. And there's my angle here, 52.415755584, which means that angle B is approximately 52 degrees. And so I can label that 52 degrees. In example 4, we're told that side A is 12, so I'm going to label that. That's side A, which is 12. Side B is 15, so down here this must be 15. And angle C is 60 degrees. I want to know how much side C, which is over here, is. Okay, so looking, I know two sides and an included angle. So in this example, I'm going to go ahead and use the law of cosines. And so in order to get side C, all right, it's going to be side C squared equals side A squared plus side B squared minus 2 side A side B times the cosine of angle C. And now I can substitute in my values. I'm looking for the side C. A was 12, so that's going to be 12 squared, plus B was 15, 15 squared, minus 2 times 12 times 15, times the cosine of angle C, which is 60 degrees. Okay, so now I'm going to go ahead and I'm going to evaluate this. C squared is equal to 144 plus 15 squared is 225 minus, okay, well 2 times 12 times 15 is 360. All right, and that, I got to get rid of that, that shouldn't be squared right there. All right, 360 times the cosine of 60. Okay, well, the cosine of 60 ends up being a half, so C squared is equal to 144 plus 225 minus half of 360 is 180. Okay, so I can go ahead and I can evaluate this. 144 plus 225 minus 180, all of that comes out to be 189. So C squared is equal to 189. And now if I take the square root, okay, well, that's going to give me a value of C equals 13.74772708. And so if I decide to go to the nearest whole value, this is going to be approximately 14. Okay, so I can say right here in my triangle that this side is about 14. In example 5, I'm told that the measure of side A is 20, the measure of side B is 16, and the measure of side C is 32. So if I know all three sides there, I want to find the measurement of angle B. So I'm going to again use the law of cosines. Okay, so this time we're looking for side B. So B squared is going to equal A squared plus C squared minus 2AC times the cosine of angle B. Okay, so go ahead and substitute in your values, and let's see what we get for the measurement of angle B to the nearest degree. In question 6, we're told that side A is 20, side B is 25, and angle C is 98 degrees. Okay, they want me to get the measure of angle A. All right, and right now I don't have enough information to get that value, but what I do have is two sides and an included angle, so I can figure out the side that's C, and then once I know that side, I can go ahead and I can use the law of sines. So let's figure out what the side of C is first. C squared equals A squared plus B squared minus 2AB times the cosine of C. All right, so go ahead and figure out the value of side C. Okay, so now that we've got the value of side C is approximately 34, let's use this information to figure out the value of angle A. Okay, I know the opposite side of angle A, all right, and I know I know angle C and the side opposite now, so let's use the law of the law of sines. A over sine of angle A equals C over the sine of angle C. Okay, side A is 20. Angle A is what we're looking for, equals side C we just found to be 34 over the sine of angle C, which is 98 degrees. Okay, so go ahead and figure out the value of angle A to the nearest degree. In our next word problem, we're told that two tow trucks try to pull a car out of a ditch. One tow truck applies a force of 1,500 pounds, while another tow truck applies a force of 2,000 pounds. The resultant force is 3,000 pounds. Find the angle between the two applied forces, rounded to the nearest degree. So we're going to go ahead and draw a picture. All right, I'm going to have one tow truck pulling at 1,500 pounds, and the other tow truck over here pulling at 2,000 pounds. Okay, and the resultant, which is going to come out in this direction, all right, we're told is 3,000 pounds. Okay, that's 3,000 right there. All right, so I'm going to go ahead and I'm going to actually finish my picture here. This is my parallelogram this ends up being. Okay, so basically if this is 2,000, then this is 2,000 up here. And if I look at this piece right here, then I have a triangle where I know all three sides. Okay, and my goal is to figure out the measure of this angle right here. Okay, well, to help me get this angle right here, I'm actually going to calculate this angle right here, which I can call angle A. All right, so I can call this A, I'll call this over here B, and I'll call this over here C. And so since I know all three sides, I'm going to use my law of cosines to help me find angle A. All right, so this is going to say A squared equals B squared plus C squared minus 2BC times the cosine of angle A. All right, well, A squared across from angle A, that's 3,000, so 3,000 squared equals B squared is over here at 1,500 squared, plus C squared is over here at 2,000 squared, minus 2 times 1,500 times 2,000 times the cosine of angle A. Angle A, again, is what I'm looking for. So when I go ahead and square, I'm going to have 9 million equals 2,250,000 plus 4 million minus 2 times 1,500 times 2,000 is 6 million times the cosine of A. All right, so 9 million equals 6,250,000 when I add those together, minus 6 million times the cosine of A. All right, so if I go ahead and I subtract the 6,250,000 from each side, then 2,750,000 is equal to negative 6 million times the cosine of A. Okay? So what I'm going to do now, I'm going to divide each side by negative 6 million. Divide each side by negative 6 million. This is going to give me the value of the cosine of A. But my goal is to try to get the measure of angle A. So in order to get the measure of angle A is going to equal the inverse cosine of 2,750,000 divided by negative 6 million. Okay, so when I go ahead and I punch this into my calculator, well, that's going to be approximately 117 degrees. Okay, so this angle right up here is about 117 degrees. Okay, now in a parallelogram, it's important to remember that consecutive angles add up to 180 degrees. So if I'm looking for this angle right here, and I know this one's 117 degrees, I'm going to do 180 minus 117. 180 minus 117 is equal to 63. And so this angle in here must be about 63 degrees.